Here's some more problems from the Larson 4.5 worksheet, and I'm calling these U-sub because most of them are U-sub, but a lot of them are not. They're just standard antiderivatives, which is like number 10, actually 11 and 12. So let's take a look at these. And all we have to do, this might confuse you the way it looks, but all you have to do is just use the distributive property and make it into a much easier problem. So that would be the integral of, if I multiply x to the 4th times x, that's just x to the 5th. And if I multiply this, x goes into x to the 4th, x to the 3rd times. So we just have minus 2 x cubed dx. And we just take the antiderivative, so that's going to equal, over here, x to the 6th, add 1 and then divide by 6, minus 2, and then I add 1, x to the 4th, divided by 4, plus c, and then we can just simplify the 2 over 4, and we just have x to the 6th over 6 minus x to the 4th over 2 plus c. Okay, number 11. This is all set, ready to go. All we just have to do is put this up on the top. So that just equals the integral of x to the 4th over 4 plus 1/3, and then take this x to the 2nd and bring it up to the top and make it x to the minus 2 dx. That's just going to equal, then we just take our antiderivative, so this would be x to the 5th over 5, and we had a times 4 already, so 4 times 5. And then what we're going to do is we're going to add 1, so this would be x to the negative 1, and divided by negative 1. I guess I can just work that out, so we'll say plus, and we have a 3 in the denominator, so we have 3 times negative 1 and then plus c, and then it ends up being just x to the 5th over 20, and we have a positive times a negative, so we can make that just negative, and we can bring that x back down, so we can have 1 over 3x plus c, and that's all you have there. Okay. And then this last one on number 12 here. All we have to do is use our distributive property to multiply this out. So we could say that this is going to be the integral of, well, actually we could take the 3 pi out and put it right in front because it's a constant. So that might save us a little bit of work. Or we can multiply it out. Either way, because we may have to multiply it out at the end anyway. So, but we can do that. Let's just bring the 3 pi out for now. So then we'll have x, and then we'll just distribute the rest. So it'd be x squared times 4, so it'd be 4x squared, and then minus, and then it's going to be x squared times x to the 5 halves. So that's going to be 2 halves, 4 halves. So this would be 2 is the same thing as 4 halves. So 4 halves, if we multiply, we're going to add. So that'd be x to the 9 halves. Dx. And then we're ready to take our antiderivative. So this is going to be, again, 3 pi times. And then this is going to be 4. If I add 1, x to the 3 divided by 3, and then minus x to the, if I add 2 halves to 9 halves, 11 halves, divided by 11 halves or times 2 over 11, All right? And then we've got 3 pi times that, and then plus c. We can call it C1, and I'll tell you about that in just a second. And then we can redistribute out if we want, or we could leave it like that. Actually, we'd just leave this. So I'm not too sure exactly how the answers in the actual problems, because these are examples that are like the problems on the 4.5 worksheet, how the answer comes out. It may be factored out, or they may have multiplied it out. In each case, 3 pi is a constant, so it would multiply times that constant, so it doesn't really matter. If we multiply, because we get another constant, that's why I call it C1, we get end up with C. So if we multiply this out, 3 goes into 3 once, so I've got 4 pi x cubed minus, and that would be 3 times 2, which should be 6 pi over 11 times x to the 11 halves, and then plus our constant. So it might be easier to do that rather than factor it out than have the constant hanging around, deciding on where we're going to put the constant, if we're going to put it inside of parentheses or outside, because it's safe either place. So you may see something like this. Okay.